In this video, we're going to talk about compound interest. Now, compound interest is an application of a geometric sequence, and we're going to be using a geometric sequence in a way that we're going to be looking for a final value. What we're doing is we're basically taking our present value. So this is kind of what we're investing. Our present value is what the IB calls it. And with compound interest, what's different from simple interest is that this present value is compounded every year. So that means that whatever money you made in the first year, you're not adding the same amount year after year, but you're taking a percentage of what you got the year before. And the formula we use for compound interest is 1 plus our rate, this is a percentage, divided by 100, and then we look at how many years are we compounding this. So this is the number of years. And this is the basic formula we're going to be using for compound interest. And in order to start with today's video, we're going to do a little investigation into compounding periods, because that's the only thing that's different from the formula that you have on the top here, is we can not only compound this every year, but we can actually compound it many times a year. And we're going to look at how this formula is going to be changed if we compound it more than one time a year. So let's start it off. If we have an investment, which is going to be $1,000, and it's going to earn a 5% interest rate per year, and we're going to start by compounding it annually, we're going to find the accumulated value of the investment after 1 year for each of our different compounding periods that we see in the table below. So first off, if we're compounding our 1,000 once a year, that means that we're going to have to take our 1,000 and we're going to be adding 5%, so 5 divided by 100, and we're doing this for a total of 1 year. So my exponent is just going to be to the exponent 1. And if we do this, we're going to get $1,050. So after 1 year, I'm going to get $1,050. Now let's compare what happens if instead of compounding the 5% exactly one time in a year, we compound it biannually, or this is also called semi-annually. So this means that we're going to be doing it 2 times in a year. Now, by the end of the year, we need to have compounded a total of 5%. That doesn't mean that we can compound 5% twice, because that would be a total of 10% by the end of the year. That won't work. So what we have to do is we have to take our interest rate per year and we have to divide it by how many times we're compounding, and then we're going to do that twice. So let me do the full working out for you for the biannual. So we start with our 1,000, and then we are going to take our 5%, and we need to separate this 5% into 2. So I'm going to do 5 divided by 2. And I'm going to take this and I'm going to do 1 full compound. If we put this into our calculator, we're going to get the value of 1,025. Now, what is happening when we're doing our compounding twice a year, biannually, is that now we do the same calculation, but instead of starting with our 1,000, we now start with the value that we got from before. So that means we're going to have our 1,025. I'm going to compound this 5%, but I'm going to separate it in 2 because now I'm going to have the second part of my year, right? So I take that 5%, it's divided by 2, and I put this into my calculator. When I put this into my calculator, I get 1,050.625. So that means that after 1 year, by compounding twice a year, we're actually making just a little bit more. We're actually making 62 cents, well, actually 63 cents more than if we compounded it once a year. Now, this is not a significant amount of money right now, but if we think about the investment, instead of having a 1,000 investment, we have a 1 million investment. Well, already we're seeing that this is going to be a $625 increase, which is very significant. So there is quite a difference between compounding once a year and compounding twice a year. And let's try with a different compounding period. So let's do 3 times a year. And I'm going to ask you to do this calculation and then pause the video and then come back to the video once you've done the calculation. So once you've done this calculation, you'll notice that what you're having to do is you're going to have to separate this 5% into 3 sections, and you're going to repeat this calculation for every compounding period, making sure that we're changing this value when we're doing the second compounding period and the third compounding period. By the end, we should have 1050.83. So a little bit more than a twice a year compounding. Now, repeating this process time and time again is super time consuming. So we have a formula we're going to be using that actually takes this into consideration. So the formula that we have, and we'll do it for quarterly, which is 4 times a year, is we take our 1,000 initial investment, we take our rate and our percentage, so 5%, and we divide this by how many times we're actually doing the compounding periods per year. So we divide this by 4. And then on the top, on the exponent, we have the number of years times how many times we're doing this compounding period, which is always going to be the same value as we have down here. So let me highlight these two. So these two will always be the exact same value. So if we do this quarterly and we put this into our calculator, we're going to get that at the end of the year, we're going to have 1,050.945. So again, we're seeing that there's a slight increase every time we're increasing the compounding period. If you go ahead and do it on your calculator for monthly, then you're going to notice that we're going to have 1,051.162 after monthly. So this brings us to the official formula booklet formula that is given in the IB. And you're going to see the final value is our FV, our future value, final value. We have our present value, that's what we're starting with. The value of N, of course, is our number of years. Let me change colors. So number of years is our value for N. Then we have K. K is how many compounding periods we have. And notice that K is used twice. So the number of compounding periods per year. And the final value in this formula is R, which is our nominal annual rate. What do they mean by the nominal annual rate? Well, that is simply what the bank tells you each year. So this nominal interest rate is advertised by the bank. Advertised by the bank, right? Good. And this is going to be the formula that we're going to be using to answer all of our questions to follow. Let's do example 1 together. Find the value of an investment of 150 invested over a 3-year period at a 6% per year, compounded annually, semi-annually, quarterly, and monthly. So we're going to be doing all these differences. And we're going to be asking what is the difference between the largest and the smallest value accumulated. So if we start first with annually. So if we are compounding this annually, we are going to be using our compound interest formula. Our present value, 150. Our value of N, the number of years, is 3. Our rate is 6%. And then our value of K will change depending on our type of situation. So compounding annually, K is going to be equal to 1. And we're going to have 150 times 1 plus 6 divided by 1 times 100. So we're going to have number of years, which is 3, times the number of compounding periods, which is 1. And that's going to give us $178.65. Now we're always going to round to 2 decimal places because that makes more sense with numbers, right? Now let's repeat the same process but semi-annually. So k is equal to 2. So that means that in the exponent, I'm going to have 2 times 3. And if we put this into our calculator, we get $179.11. And then we can repeat quarterly. Quarterly means that k is equal to 4. 179.34. And then the last one is monthly. So monthly means that our k value is going to be 12. Good. So this example was to practice with our new formula for the different compounding periods. Let's go and increase our level of difficulty with example 2. Joe invests $2,750 at an unknown interest rate. So that means we don't know what R is. We know our present value. And it's compounded annually. So compounding annually means that k is equal to 1. At the end of 10 years, that's our value of n, this investment is this much money. So at the end of 10 years, that's our future value. Find the interest rate at which the money was invested. So using our equation for compound interest, we're going to build this equation by replacing the values that we know into the equation. So our future value is 5,409.67. We start with 2,750. 1 plus our rate, we actually don't know what it is. We're compounding once a year, so 1 times 100. And we're doing this for 10 years. And now we just create an equation which needs to be solved. So we're going to be using numeric solve in order to solve this equation. So take some time right now and put it into your calculator. And when you solve this, you're going to get that the R value is equal to 7%. Example 3. Determine the minimum number of whole years necessary to triple an investment in an account that pays interest at an annual rate of 5% and is compounded monthly. Compounded monthly, k is going to be equal to 12. Okay, so if we think about this, now we're looking for the number of whole years. We're looking for n. We want to triple our investment. So if we start present value with 1, then we want to triple that. So our future value needs to be 3. So we're going to write our equation using the compound interest formula. Our future value needs to be 3 times bigger than our present value. 1 plus, we have an annual rate of 5.1%. We're compounding monthly, so that means we have 12 as our value of k. And we're looking for the whole amount of years. So we're looking for the value of n here. So now we're going to go back into our numeric solve, and we are going to calculate this. And when we solve, we get that n is equal to 21.59. Now the question asks, determine the minimum number of years in order to triple an investment. So the tripling of the investment will happen during the 21st year. So therefore, it's going to take 22 years in order to triple this investment. Now, another concept that's often used with compound interest is depreciation. Depreciation is when an object loses value each year. When an object gains value each year, then this object is said to be appreciation. So there's a difference between appreciation and depreciation. Appreciation is what we were doing with our compound interest formula, right? So with compound interest, we're actually calculating appreciation. But if we're calculating depreciation, then we're going to use a slight change to our formula. So first, let's think about some objects that can either depreciate or appreciate. So if we think about depreciation, then we're thinking about a car. So a car loses value year after year that it's being in use. Same thing for any electronics, like a computer can lose value, your iPhone can lose value, right? Things that can appreciate are a house, right? So a house is an investment. You might buy it for 100,000 and then you're able to sell it later for 200,000. Artwork often is in appreciation, so it gains value, and so on and so forth. So if we have depreciation in the IB, this is only done annually. So we're going to be using the compound interest formula. Now, since we're losing value each time, we're going to have that our future value is going to be the present value times 1. Instead of plus for gaining, it's going to be subtracting for losing. And since it's going to be done annually, we don't need to really have the value of K here. We're just going to have the number of years. So when we're depreciating, it's going to be a negative sign instead of a positive sign because we're losing value each year. Let's look at our examples. So example 1. An industrial dishwasher was purchased at £2,400 and depreciates at a value of 15 each year. Find its value after 6 years. So after 6 years, we're going to find the value of this dishwasher. We start with 2,400. 1 minus, we're depreciating by 15%, and we're looking for what is the value after 6 years. So after 6 years, we are going to have 905.16 pounds is going to be the value of this dishwasher. Part B. By how much did it depreciate? So by how much did it depreciate? Well, it was originally worth 2,400 and now it's only worth 905.16. So if we put this into our calculator, it depreciated by 1,494.84 pounds. So quite a substantial depreciation for this washing machine. Which would make sense because if we think about this logically, a dishwasher is not supposed to last you over 20 years, right? So after 6 years, it's already done a quarter of its lifespan maximum, right? So it makes sense for it to be worth a lot less. Good. Now the next part of this video is going to be about inflation. At this point, I'm going to ask you to pause the video and we're going to be looking at inflation in class as our starter question.